ahead, some people work behind it. It's just, you know, how we all handle like our priorities.
It's really gonna screw me over next year, but
Well, maybe we'll have to shift how we do things then. All right, so grab a seat, grab a piece of graph paper. We are going to help. I don't even know how to say that name. I would think it's Nijin. So she loves to make string art. Negan. So she notices that on this piece of string art that she just made, which you've probably maybe seen things like this because they're now starting to become popular, where people put nails in pieces of wood and they tie string back and forth, and then it either just kind of fills the space or sometimes ends up looking kind of geometric here. So we're going to kind of investigate this by following these steps right here. So it says on tracing paper, we're going to try to do this on graph paper, and it'll actually let us get a nice straight line. So go ahead and make line L, ooh, what a fancy name for a line, on your graph paper. And then point F above line L.
like in the middle of line L?
Yeah, like in the middle of your paper, relatively, but above it, far enough that we... So you might want to read the directions before we decide where to place these things. We're going to end up folding our paper so that line L, when it comes down on the fold, goes through point F. So this is why we need to kind of try to be able to see through the paper. So we might make point F kind of bold. Like we could use a Sharpie, or we could... maybe. I don't know if that's easier to see than if I just like use a Sharpie.
Does that have to be exactly in the middle?
No. So then we're going to start folding. And I actually think I'm not going to use a piece of the reinforced graph paper since we're going to fold it a bunch. I'm just going to try to get a piece where it has the plastic on it.
Oh, you mean the stuff I grabbed?
So I'm going to grab like a piece like this just because, yeah, I think it might fold a little easier.
That's a big L.
So line L, point F, and then we're going to fold.
I'm making point F darker, line L darker too, so that I can see it.
So for example, now this is hard because it's not tracing paper, but I can kind of see through this.
I think I got it pretty good. I think I got it close enough.
So yeah, I don't know if this is really going to work or not, because I thought I could find my tracing paper quickly. Which makes me feel like I want to look for it again.
We can just play with toy cars.
That's for Math 7, and I heard that you played with those in Math 8.
Oh, we did. I remember. Wait, in Math 8? No.
Or, like, 8th grade science. So that's what I meant.
Yeah, we did.
Yeah, I do not know where my tracing paper is. Makes me feel like I loaned it to somebody.
Okay, I got the line and the point. Yeah, I got the fold.
So then you're supposed to fold a bunch of times so we can start to see a pattern. Oh, here we go.
Fold a bunch of times so that L is still on point.
So if you would like to do this on tracing paper,
Yes, please.
it will be easy.
I don't get this. Oh, it's what you found tracing paper? Yes. Great, I can get rid of that crap. Yeah, also, I'm not sure how we would see the pattern if we can see through the...
Well, because the folds are really what is going to show us the pattern. So you guys know that I like using a ruler. So I'm using a ruler, but you don't necessarily have to. And then point F. So then, like there would be one of the folds. Right? Because my line covers up point F. I can do another one kind of from the other way. Yes, I mean we can't fold a piece of paper 20 times. I'm pretty sure that's actually impossible.
I think if you take a piece of paper, I don't know if it's this big. I think it might be a bit smaller. And you fold it like, I remember we did this in a class once in science class a couple of years back. And you fold it like 14 times or something. It's the size of an atom if you fold it in half. Oh wait, you can fold it kind of like back on itself, like this way. The pattern I'm detecting is that I'm not very good at finding it.
Actually, is missing a fun lesson.
We should tell her that. In detail.
Also, a valuable life lesson how to fold paper.
Dude, I don't know.
Tracing paper is much easier to fold than other paper because it's thinner.
So we're just trying to find the most ways to.
Yeah, so you should start to kind of see something happen.
It's only really folding on one side of the paper. There's also, I think it's making like a point. Is it?
Just make it a parabola.
Is it?
I'm getting a parabola.
I'm getting a lot of lines. I'm not.
I'm getting
Yeah, I do see how you would get a parabola. No, I'm not talented enough to do it correctly, so. Wait,
So-
I can really find like three ways that work.
Did anyone have any difficulties based off, like, you think your point was too close or too far and then you, like, modified it? Or do we think we were okay with where we put point at?
I don't know. I think I did it.
So, hard to see under, I don't know if it's even possible to see under this, but, like, as our folds start to stack up, I think Jake said it's looking parabolic.
I got the tangent
So I
line to the
follow
bottom.
my,
I got this.
dude, I can't really see from here, but if you want to put it under the dot cam, we can.
Did you get the bottom to the parabola, like the tangent line to the bottom of it?
Yeah, what?
I was just wondering if you had thought of it that way. But I see how this would make a parabola if I was better at folding it. You know?
Folding skills elite.
So, what we're actually working with here is what we call the focus point, or just the focus, and the directrix. So if you would like to label on your paper, the line that we drew is actually called the directrix, and the focus is this point. Now we're going to need your Chromebooks out.
I have a question.
I have an answer maybe.
Why do we call the directors L?
Right? Line L. But we're going to dig into what the heck is the focus and the directrix.
Well, I know what the directrix is.
What is the
I can
directrix?
guess what the focus is. It's all the tangent lines to the parabola when it's rotated around the focus.
Wait, what?
Like you rotate it or no? Because you're folding the paper.
It's the tangent lines to the focus at a certain distance away.
Tangent line to the focus, but it's not even touching the focus.
They make a parabola when you fold them like how we did fold them. And then it's
Okay.
Wait.
So there's a parabola made like here, or when we folded
Well,
like
it's
in
the middle of
here.
the parabola is actually a little bit above. It is halfway. The vertex of the parabola is halfway between the line and the point.
Well, so pull out your Chromebook. Go to the ebook. The ebook.
Does it have a fun tool that we can use?
It does have a fun tool that we can use called the 1027 Etool. So go to problem 27. So you're going to go our book, chapter 10, 1013, and then problem 27. I need to give you a second to get in there probably.
Yeah. That name is really terrible though. I do have to.
What, Directrix?
No, the 1027 tool.
Oh, yeah, they could have been more.
Creative. Fine. Jabby.
Down with the kids.
Down with the kids. They could have been more.
So I didn't want to just have you do the e-tool because not actually playing with stuff is no fun, but we didn't have to do the paper folding thing. The e-tool that you pull up should look like
Would be an
this.
ebook.
Yep, so go to the ebook. So-
10.7 student Etool.
Did they like
So in your book,
the entire thing into Desmos? Or
10.1.3.
does Desmos have a feature?
1027. Right here. 1027 Etool.
Okay.
And start moving stuff around and playing with this. I think these points are clickable. I think they're movable.
Yeah, but it's a lot. Like we can just move the line.
Oh,
Like,
that's
oh my
I mean,
God.
I can move the focus. I can move whatever point P is. I think I can move the
He
directrix.
does nothing. Oh, it's just a measurement tool. I see. But we can't really rotate the direction. If they're the same point, it doesn't make a parabola. Believe it or not.
Well, if the focus is the directrix. Oh, hey, look.
Wait, what happens when you move it side to side? It kind of. Oh my, good, oh
Oh my good golly.
my golly. It kind of like swerves.
It swerves.
I don't know. Words. That's not why I'm in math class to do words. It gets thicker the further it is away from the director.
I made the parabola be a bird.
How? Wait, no, it doesn't.
Almost ripped all the way.
Oh, because it's all long. Oh my goodness. I'm so
It's
stupid.
flapping its wings, essentially.
But, well,
Alright, so Jake is back there flying with his parabola.
well, okay, so the further the point at the focus or whatever, oh, you can make it go upside down too. The further it is from the director, the chunkier the parabola. I feel like point P is important.
So, you said the closer the focus gets to the directrix, and then it disappears. But so if it's close to the directrix, the parabola is steep.
Wait a second.
If the
Point-
focus is far from the
Oh
directrix,
my goodness, point P is so amazing.
Why would it do?
Because so the distance from point F. Oh, because that's how full. Oh, okay, that's cool. The distance from point F to point P is always the same, at least
As
so
the
far.
as the y value of the parabola.
As the no, it's the distance from point P to the directrix. They're always equal.
so careful, the directrix is not always the x-axis. It could be, but do not fall in the trap of assuming that the directrix is the x-axis.
Yeah, they make an isosceles triangle. Point P.
They can make an acute one, can't they? If you like, yeah, they can make an acute one. If you move point P like really far out. It's
Well, I think by isosceles he's saying two legs the same.
Oh my goodness! I thought you went obtuse because I don't know words. Yeah.
So what Connor pointed out is from F to P is going to be equal to P to the directrix.
Is it an equilateral triangle? Yeah, F to P is always equal to P to the director.
I don't think Jake's saying no. I think he is making his bird fly. I think he is doing this.
Oh.
So those are the noises that you're hearing. I don't think he's disagreeing with you.
I'm not disagreeing.
Oh, okay.
Making the airplane noise.
So wait. So we said the focus and the directrix, between them is the vertex of the parabola.
And also any point in the parabola. The parabola always is going to be in between them.
The parabola is always going to be in between.
The directrix and the thing. So you can find the focus by just going up from. If you have the directrix, you can find the focus by just going up from the center of the parabola from the directrix.
Ah.
And then go to that value again. But if you have the focus, I guess you can just do the same thing. And if you have a parabola, you're kind of screwed.
You're what?
I said you're kind of screwed. Well, I don't know. Because you could take a point on the parabola. No, because, wait. With a parabola be the same if we like take the focus? Right. Okay, I've messed this up like drastically. I want to move this to like 0, 31, and this is gonna be.
I'm trying not to rush. Like, I'm trying to give you guys time to play with this.
Into a line.
Okay. Wait. How?
Move the Directrix really far up and then zoom in really far on the parabola.
Well, that's not a line.
This is what it looks like in your current zoom.
That's like me just like taking a circle and being like, this is a line, because if I zoom in 3,000 pixels, it's a line.
So, this shows us the formal definition of a parabola, which we've already kind of said, but we want to formalize it. So, a parabola is all of these point P's, right, because those move, that what?
The distance from point F to point P and the Directrix to point P are the same.
The distance from the focus to that point, any point on the parabola.
Well, the closest point of the Directrix to point P, or the point like directly, like a right angle.
Yeah, so if we drop an altitude, right, if we want to call it, because that's going to give us the shortest distance. So if we drop an altitude from a point on the parabola to the directrix, and then draw the line to the focus, it's equidistant, no matter what point on the parabola I look at.
Wait a second.
And like you guys said, even if I make the point P right between the focus and the directrix, it's equidistant.
This means now we can turn lines into parabolas.
It does mean you could.
I don't know what point F. I don't know what line in a real world situation you would have that then you then have a point F that you're given that make it a parabola.
So you guys have this paper, the handout that I gave you, this paper, and I bet that without me even really saying anything, based off what we just said, and we don't really need our Chromebooks anymore, I don't think, I think that's it for Chromebook today. So we could probably put that away so we can avoid the temptation. So I'm guessing that if you start investigating this paper and playing around with it, that you guys can start to see some of the interesting things that we're trying to get you to see. So take a moment and just start playing with this paper and see what you sketch out. And I can actually make more copies of this paper. So if you sketch so much on this that you decide like, oh crap, I want a new one. But keep this paper because we need what's on the back. We're going to do that, but obviously not today. It's 10-2-1. So keep this paper. So don't write on it with anything too heavy. Like don't use a Sharpie.
We can make like half of a parabola, I think.
Yeah, so this is interesting. Now we've got a bunch of concentric circles. So go ahead and just play with this for a minute.
I'm not sure how I play with the paper. Like, I can eat it. Do you think that'll help? Okay.
Do you need me to explain it again, or are you just doing the 8th grade thing where you act like you don't understand what I mean?
I don't know. I don't get how you play with it.
So, like, if I let my eyes kind of unfocus on this paper, I see some shapes.
I see thick boyo circles as opposed to less thick boyo circles.
That's cool.
What is cool, Jake?
Check this out. You can use the lines for like the points where the circles and the lines meet, and you can make parabolas.
You want to throw it under here?
Wow.
Parabolas.
Parabolas.
What about parabolas? Oh, that's cool.
So your focus would be somewhere up here or somewhere down here, depending on the parabola. Yeah, is what we're saying, because it needs to be like
And your
equidistant.
Directrix would also have to be below.
And the directrix would actually have to be below, because the directrix can't be on the parabola. So, okay, what if, instead of saying, okay, the directrix would be somewhere below, what if we say this is the directrix? Can you sketch out what we can do? I might actually run a couple more copies of this. I'm just going to send them to the printer, though.
let's see a parabola.
So if this horizontal line is our directrix and we make our focus at like 4,
At 4? Okay. I can do that.
then where should the vertex of the parabola be?
2.
At 2. I'm actually going to change colors. I shouldn't really be writing on this one because these are actually handouts that I made double-sided for you guys. So I'm going to go pick up these extra copies.
Oh, this makes a really nice parabola. Because it goes like on all these diamonds. Or I'm just making crap up. You know? Actually, this might be if the Directrix was. I made a parabolic shape. Oh wait, but that goes down there. Oh, that's what you made early. I see. I figured out how to do his thing, but I haven't figured out how. It should be as thick. This might be right. Is it like this? There are a lot of different parabolas with that vertex that you can make. So how
With that vertex, yes.
that,
With
yeah,
the
so how
focus
do we use
location.
the focus? With the focus, there also is a sufficient amount. So how do we use the focus in the director to be able to? We know it has to go up at least. That's pretty good. Wait a second. We know the. Wait, this is not actually as hard as I thought it was. We know the focus location. And so, if this is 1, it has to be 1 away from that. So. I'm not sure how the paper helps with this, but I think I figured out how to graph this.
So if we try to use that line that we have on the paper as the directrix, you're saying it's kind of a pain in the butt? So we've got horizontal lines on there that we could darken up. So what if we let that center point, so I gave you new copies, right? Grab a new copy real quick. What if we let this middle center point be the focus?
And then what's going to be the director?
Well, we'll have to draw the directrix once we pick where the vertex is going to be.
I think we should make the vertex -2.
Sure. Let's make the vertex -2. You with us, Jake, on a new piece of paper?
That isn't 1, and I feel like 1 always acts kind of different. You know?
So then, I think the next points would be like here, maybe there.
Wait, okay, I understand.
This is the problem with me teaching certain things only once a year. I'm starting to get a little lost. I don't know if these points are
I understand
right.
how we could do it on graph paper, but with this kind of shape, it just seems kind of weird.
That's a poopy word.
Where are you?
Now wait. This is radius of 2, right? This is radius of 2.
Oh yeah, it do be that.
So wait, so our directrix, if you said if this is the focus
Yeah, our directrix.
and this is 2, our directrix would be down here.
Yeah, but the thing is, that's 3 away, so that's not the.
Well, hold on. 3. What is 3 away?
Those
This?
dots that you made.
Well, this I think is wrong. Like I'm worried. That's why I stopped myself.
That dot, I think is wrong.
I think this dot is wrong.
But
I
I
agree.
think your 2 on the left and right can't be right because the 1 is 2 away, right? But then like it's also 3 away from the director.
I think
And they have to be the same away.
Ooh, yeah, you're
So it
making
should be
a good
little
point.
below that.
Okay, what if? Sorry, Jake. You said what now?
So I have an idea.
Okay, what's your idea?
So I think that every time you go out to the side, you go up by 1 more. So we went out 1 point on the side this time. So next time we go out 2 and up.
So these should be equal 2 and 2. Right, which because they're straight, we can measure it like you guys were saying if it was regular graph paper. But the next point on the parabola, you're saying is going to be more than 2 or less than?
Wait, I know another point that's on the parabola.
Okay.
4 is 0, right? Because the directrix is -4, so it's 4 away and it's 4 away.
Wait, okay, hold on. I think I'm catching up with what you guys are saying. So if I try to use this point here. Oh, thank you. I realized that I went and chatted with Colin about it, and he was like, Chromebooks have stopwatches on them. And I was like, oh, I'm an idiot. I didn't think about the Chromebooks. All I thought about was the kids' cell phones. I was like, oh, no, I'm good. And now that we can use their Chromebooks. Thanks, man. We're trying to figure out what the heck a focus and a directrix is, Mr. Hall.
The focus and the directrix.
We're playing with it.
Are we doing like ellipses and
Talking about parabolas, but yeah, we'll turn into more stuff. But we had this.
do you generate equations for parabolas in that too?
Yeah.
Well, you guys, yeah,
We did those.
You generate equations for quadratic
yeah,
equations
from the
for parabolas?
binomials and things. So we had this activity that helped us investigate that apparently these distances are equal to each other, but now we're trying to figure out how to draw that. And we've got this special circle graph paper, but we're
Hyperbolas also have that, and
don't what?
hyperbolas.
Probably. Now you're going deeper than me because I only get to teach this once a year, and I can only go so deep,
All
right?
Back at it.
So wait. So if this is a point on the parabola, this would be 1, 2, 3,
Yeah. So it has
and
three
1,
other ones.
2, 3.
Oh, because there's circle. Oh my. Oh
So if that's 3, and if that's 3, so you're saying this is where the point should be?
Oh my
So wait,
goodness. This
3
is actually
circles.
so much easier than I thought it was.
I think if we grab that other clean sheet that we had, what if we just make it like 1 away? What if we make the vertex of the parabola at -1? Then the directrix would be at -2.
Oh my goodness. This isn't as hard as I thought it was.
All right, do say more, please.
Well, because like how you did that, yeah, you just you take like the x value of whatever the point is, and then that has to be equal to how many circles out you go. Instead of like a y value, it's how many circles out you go.
Okay, so if this is my focus,
Yeah.
and this is my vertex, and this is my directrix. So then give me another point to place.
So you go for x1.
X at 1.
You know it has to be right there because it's on the circle number 1 from the middle.
But aren't I 2 away from the directrix then? I feel like
no,
if
it's y. It's y. It's the difference in y from the directrix. So yeah, it has to go there.
so I think X at
Not
2.
x,
I'm gonna change a brighter color.
you have to take you take the distance from the directrix, and that equals how many circles out you have to go for any point you want.
The distance from the directrix, how many circles? So if this is 2. So if I go 3 from the Directrix.
You have to go 3 circles out.
I need to go a third wait, I am already. Okay, so here then?
Yeah.
So 4 from the Directrix, I go 1 up. Oh, and another circle out.
And that intersects with the lines. So I think you can just keep going up like through those.
Because every time I bump over 1x, I go out another circle. So I kind of go out and then ride it around. Out. And... Go ahead and draw these points on here. 2. So this is where I need Connor to try to say it again differently. I'm bad at teaching this. I will just be straight up. I think that your explanations are better than mine. Do you remember how to work the pen up there if you're trying to write on the board? Click the little arrow if you want to be able to write things, and then it'll stop like refocusing.
Okay.
There you go.
So this.
You cannot. Now hold on. So wait. Answer Jake's question. So
no, you can't have a point on like up row. No.
We're not using.
Directrix is the green line.
Oh,
here.
I didn't see anything.
It's kind of hard to see. Yeah.
Okay, that makes more sense. I'm not so confused anymore.
Okay, so but do you understand how we got all these other points?
Yeah.
Oh, okay. So you were just confused because you thought we were playing the Directrix
Yeah, I
and
thought
one not
Directrix
different.
was
Okay. I see.
Yes, I don't actually love that they made the x-axis so bold here because it does kind of lead your brain to thinking that's the Directrix. So the Directrix is down here at this green line. I probably should have used highlighter or something heavier.
Red.
Guys, and I've not taught Math 2 as many years as I've taught the other classes that I've taught, so I am still trying to get better at teaching this stuff. When I first started teaching, we just didn't offer it at Phoenix, and then Math changed, and we had to reorganize the schedule and stuff. So, yeah, and CPM teaches things differently than how we used to.
Was that recently? When digits went out in CPM?
I taught Math 2 under digits, but it was very different. Actually, I didn't really use digits because it was a high school course. I will reserve my opinions on that.
Why?
What you heard is not wrong, because I could go off on a big old tangent on the reasons I did not like
Well,
it.
we're talking about
So,
tangents.
if this is our focus point, right, I'm just going to go ahead and label, that's our focus. Then what we're saying is the radius of the circle comes back to the focus. So if we want an easy-ish way to measure, we make the focus the middle of our circle. Right, so when we were trying to do other focuses,
Oh, so we could do this.
That
with,
wasn't
just,
like-
if we didn't have the graph, we could do it if we had like a compass and like stuff. But it'd be a lot harder. So you shouldn't make us do that.
so
But we could.
if we're 2 away from the Directrix, we're 2 away from the focus. So this point right here is the easiest to understand. It is 2 radiuses. And this is 2 radiuses because we can count over here at like where the y-axis is, right? So same with this point. It is 2 radiuses and 2 radiuses. So 2 units. Radii, sure. So then 3 radii can't be here because that's only 2 away from the Directrix. So to get 3 away from the Directrix, we got to come up here. And even though it doesn't drop down straight through, we know that that is 3 away from the Directrix. Because the horizontal lines on our paper are all evenly spaced at 1 unit.
And if you only look at those two, and like, if you only look at 2 points next to each other, it looks like
Gee.
kind of they're.
Did you go from confusion to needing to bang on the desk? Sorry, Connor, you were saying?
Oh, sorry. It looks kind of like, for those first couple points, it looks kind of like it's just going up in like a y equals x kind of thing. But like, then it gets smaller, and I don't quite understand why.
So wait, now that we understand what we're doing a little bit, if we go back to the other one that I think I had started to try to goof up, I'm going to use blue as the correct color here. So if this is our focus, and this is the bottom of our parabola, this is 2 and 2, right? 2 and 2.
So then we need to go 3 away. So it's the third ring, and it is that red point thing.
So 3 away, 3, so the red point is correct.
Yeah.
Okay, so this is 3 and 3 now. So ignore the green points.
And then you go 4 and 4, which should just be the.
So 4.
It's
And
just
then-
on the x-axis. It's the fourth circle.
So that green point needs
thrown
thrown away.
kind of like through the diamond shape. No. 'Cause
So
it
wait,
goes out
5.
one ring and it goes up one.
5, 6, 6, 7, 7. Oh, so now we're following those intersections. So kind of. I should really use a pencil to sketch graphs. And is this linear? No, but it looks nice because how the circle graph paper's been made to measure outward from the center as
I
opposed
feel
to
like
like
a linear line would look kind of wrong on this graph.
right. So we can do the same thing over here. Got 3, 3.
Is that why
ways of the-
parabolas always look so weird? Because we're just graphing them on the wrong graph?
I mean, that's kind of one of the reasons they're difficult to graph on a Cartesian plane, which is the regular XY axes, right? Cartesian plane. I don't try to use fancy words often, but you guys are at that point where like the Cartesian plane is the XY coordinate, just like equal things, right? It's a Cartesian plane.
Who invented it?
Some dude, I forget, his last name had something to do with like,
Cartesian?
yeah, like, yes. Or it was from the culture, or I forget where that name came from. Research it if you want to. This is how you guys are smarter than me. Cartesis.
Cartesian, maybe? Like, maybe related to that.
All right, so do we understand then how the points of a parabola get made, being equidistant from this center focus and the
circles are
directrix?
Cool. Now I understand how this relates back to circles. It's because circles are cool.
And we could do that. So, you want to try another one? Bigger?
Bigger.
Well, I'm curious. So you guys said as we pull the directrix away from the focus, the vertex of the parabola will always be the midpoint, essentially.
Yeah.
But then what did you say
It'll
it does?
Spread out like.
How it spreads out. So wait, will it still look nice if I do like a... Let's do directrix. I kind of want to do like... Do you want to do directrix at like -8?
Mr. Hudson, do you have another paper so that it doesn't get confusing?
I can print more. Because you guys have already used everything I printed for you, right?
Wait, I actually think I have one extra one.
Do you have a clean one still?
Because I was like watching on the board to understand what was going on.
I can also just put it on the board if we want to do it at the board.
Yeah, we can
Yeah,
do
just
that. And
draw it
then
on
we
the
can
board.
easily erase it.
Actually, so that we can scooch around, I think this lesson should have a copy of this. Haha. All right, so now we can slide up and down, and our points will stay where they are, as opposed to like writing on the screen. So what if we made? Let's go ahead and do the directrix. Let's cheat to do the directrix. Where do we want to put the directrix?
-10.
Negative
Because then we have
10.
the nice -5 that tells us like that's right where we put the point.
Is that dark enough?
Just add more colors into it. Oh, I think the blue definitely works. Except for
All right, right about there.
Jake, can you tell that's the director?
No.
All right, so where should the center point be then?
The focus?
Or the okay, so the focus is here. I hate that it doesn't let me make that.
Because if we didn't put it at the origin, it'd be real. Something.
So, if we were trying to make a parabola, essentially we would just draw circles out from the focus, is what you're saying? Okay. So then our vertex of our parabola should be -5. All right, take it from there. You might have to tap the pen up there. Sometimes it doesn't like keep it registered.
1, 2, 3, 4, 5, 6. It's this circle. Wait, it's this circle. And then we go. That's 6. No.
You take one side, I'll take the
I
other
had
side.
the exact point, and then it was like, you know what? Nah.
You know what? Nah. You guys might only be able to have
Seven
one person
circle.
writing at a time.
And then, yeah, we just go like this. The first one's really the only hard part. Then you have the nice little diamonds. And wait, actually, there's a diamond here. It's just a really squished diamond.
So wait, if we hit
It's
the
just a
back
really
button,
squished-
I think we might be able to see what you're saying.
It's a really squished diamond right here.
Ah.
So we don't even have to do any math. That's the best math.
The best math is when we don't do math.
The best math is when
Now,
we
if you
do
really
math.
want to cheat, If you really want to cheat,
Is there a parabola?
There's an ellipse.
I
You can
feel
make
like
it
in certain
ellipse.
there was a certain math tool. Or no, sorry, I'm thinking of Desmos. I think Desmos has the parabola tool, but we don't in here. But literally, when you go to graph a parabola on like a tool like this that lets you graph the parabola, you normally click the focus, and then you're setting where the vertex is, right? But if we made this parabolic, so does the ellipse, does this create parabolic?
It kind of does.
If we make it big enough.
Like
Okay.
an ellipse is kind of two parabolas like put together nicely.
Okay,
I feel like.
interesting. We are out of time, sadly.
That's
We're
unfortunate.
out of time today. But I think what we learned in this math class is we don't have to math to do parabolas.
Yeah! Well, we have to compass a lot if we don't have it already digital.
If you didn't have circle graph paper.
Yeah, circle graph paper is a great invention, and whoever invented it should be very proud of it.
There is like every type of graph paper you can imagine.
Wait, what? Can you pull it out for us a little bit?
He's getting there.
Oh, is it a semicircle?
So now the problem is you have to get to the corner of it to drag it. So you have to grab this corner to be able to drag. So like grab this one, and it'll let you change the size.
Well, I just want to expand one side, not just make the whole thing bigger.
Problem is it's broke. Like it keeps you fixed at a symmetric relationship. All right, it is lunchtime for what it's worth.
You can't use that corner. He's trying to make the perfect. Jake, it's not going to work because it's a circle, not a parabola. And they're two different shapes.
So you're saying the slope won't change at an increasing rate like we want it to because it's staying too consistent?
Well,
Close enough.
I don't know. Parabolas and
Well, I
circles, I feel like are different. But
was about to say, are we arguing that if I drag this down, it's pretty much circular? Yeah,
Yeah.
it's pretty
because
close.
it's a semicircle.
Yeah, this is semicircle tool, right? So we may not have the same perfect matching circle, but it's a
Well,
semicircle.
we don't have a perfect matching circle because this is the circle's diameter, and you set it all the way down here.
Yeah, oh yeah.
You don't have a matching circle because you're trying to put a smaller circle in a bigger circle.
All right, so tomorrow we might review this really quickly. I may need you guys to explain what you have learned through today because I don't think I'm great at teaching it. But yeah, you already know what problems to do from 10.1.3 tonight, so tomorrow we will dive into 10.1.4.
Can tracing paper be recycled or no?
Yeah, probably. If not, it gets filtered out.
Oh, really?
Yeah, recycling plants are fascinating.
Like, it's not that that's no reason to like be recycling like a ketone state or anything.
Oh, correct.
But like,
But like if it's a certain type of plastic that can't be recycled,